This is a quick review of section 1.3, 1.4. Students will be able to solve linear equations, and students will be able to isolate a particular variable in a formula or equation. Okay, so when you're solving equations, there's always a variety of things to think about. One is that you should first ask, should I get rid of a fraction by multiplying through by the lowest common denominator? Should I use a distributive property? Should I combine like terms on each side of the equation? So these are questions that you need to ask yourself. In this order would be good when you're solving an equation. So is there a fraction, distributive property, combine like terms on each side separately? Next, you're going to ask yourself, should I combine like terms by moving terms from one side to the other? This is collecting like terms. How am I going to isolate the x? Should I add, subtract, multiply, or divide? And then last and really importantly is that does my answer make sense? Do I need to simplify? If it's 2/4, you would need to simplify it to 1/2. We're going to go through a series of examples from the notes that we did. We did obviously more in class, and hopefully that'll help you remind and refresh your memory. Let's go through the first one. 4x plus 9 equals 21. So if we go through those series of questions, there's no denominator. Don't have to worry about that. There's no distributive property. If we look on this side of the equation, there's only a variable term and a constant. Can't combine those, so we can't combine. So we need to collect. We need to take this plus 9. Oops, sorry guys. Let's go back a step. Let me grab a pen. We need to take this plus 9 and we need to move him to the other side. We need to zero him out. So change sides, change signs. So now we have 4x equals, well, what's 21? Take away 9. That's 11. Take away 9 is 2. I had to borrow, so that makes it 12. And so then x would have to equal 3. Okay, let's try another one. Okay, so same series of questions. There's no lowest common denominator. There's no distributive property. I can't combine these two, nor can I combine these two. So in this case, I have to collect like terms. I have to take and move all the constants to one side of the equal sign and the variables to one side. Your rule of thumb is when you're moving and deciding, look at your variable terms and look at which one has the bigger coefficient. You're going to keep the bigger coefficient there, so that means I'm going to take the negative 6r and I'm going to move it to over with the bigger coefficient, which means the 25 is going to move over to the left. The 17 was already there, so it's minus 25. Negative 3r was already there, becomes plus 6r, and then you simplify. So that's negative 8. That becomes 3r. Divide both sides by 3. So you have negative 8/3, and you cannot simplify that. Let's keep going. Okay, so you can see in this one there's no fraction in order to get rid of the common denominator, but there is a distributive property that we have to apply. So that's that right there. So we're going to apply that before we collect or combine. Distribute. So we have 2b plus 6 equals 4b minus 2. And remember, that's a 6. And now again, we look at which one is the bigger coefficient. This one. So that means we're going to take this guy, throw him over there, take this guy, throw him over there. So we have 6 plus 2, change sides, change signs. 4b minus 2b. So now we have 8 equals 2b, divide both sides, and you get b equals 4. Okay, try the next one. Okay, so this one you can clearly see that there's a distributive property that we have to apply to both sides. So we're going to first apply the distributive property to the left, and then we'll do it again to the right. So that becomes 3m minus 15, 6m plus 6. Let's see, 3m, 6m, this one's got the bigger coefficient, so I'm going to keep the 6m here. 3m is going to move over there. That means this is going to go over here. And so we're collecting like terms. So now we have negative 15 minus 6 equals 6m minus 3m. Continue to simplify. That's 3m. m equals negative 7. All right, keep going. We have here. Okay, this looks pretty messy. So again, there's no fractional coefficients. I do notice distributive property on the left. These arrows are great reminders. Keep using them. So let's apply the distributive property first. Plus 16. And then we're going to look at each side individually. Say, can we combine these two? No, they're not like terms. What about anything on the right hand side? Sure, we've got like terms here. So we're going to combine those guys. I'm going to carry down the left. Let's see, 4w's, 4w's, 8w's plus 16. And then we can start moving terms around. So 10 is the bigger out of the two variable terms. So that means I'm going to keep the 10 there. 8w is going to move over with him. That means this guy's got to move over. So now we have 10w minus 8w equals 16 plus 40. I'm running out of room here, so I'll move it here. So you have 2w equals 56. Divide both sides by 2, and that gives you 28. Okay, alright. Let's go on. We have a couple more examples. So the second objective was dealing with formulas and equations and multiple variables. So this is your perimeter formula for a rectangle. Twice the length plus twice the width, but we want to isolate this L. We want to get it by itself. So how do we do that? Well, in order to isolate this L, we have to move this plus 2w over first. Change sides, change sign still applies. 2L. We're almost there. I want to isolate the L, so I'm going to divide everybody by 2. You can also divide this whole side by 2. So there's a few different ways. And then this is 1. And so you have L equals the perimeter over 2 minus 2w over 2. You could have also written it like this. It's the same thing. All right, I think we have one more with the same objective. Same thing, we want to isolate the r, so I want to get the r by itself. So that means I want to get rid of the 2 and the pi. So we can kind of do this in one shot. If I want to get rid of the 2 pi, this is a product. So I want to do the inverse operation, which is division. So I'm going to divide both sides by 2 pi. 2 pi divided by 2 pi. Anything divided by itself is 1. And then we have r equals the circumference over 2 pi, r being the radius. Okay, hopefully that helped. You can watch it over again, you can pause it. And this was a quick review of 1.3 and 1.4.